Hey everyone. Hello in the room. Hello to those online. Harrison, glad you could make it. So welcome to the Water Resources Institute Spring Seminar Series. It's entitled Catamounts, Catalyzing Change. And so during this seminar series, we are highlighting UVM alumni that focus on impactful water work across the nation. The series will dive into their current work, as well as how they navigated their path from UVM to their current career. My name is Eric Roy. I'm a professor, also director of the Casella Center here at UVM. And so I'm really excited to introduce our speaker today, Dr. Becky Tharp. She will be giving a seminar entitled Damned If You Do, Water Quality Science Meets Energy Policy in Vermont Hydropower. So just a little bit about Becky. Currently, she's the owner of Just Water Consulting. She's been in that role since 2019. In the past, before that, she was the Water Quality Program Manager at Watershed Consulting Associates. Before that, the manager of the Green Infrastructure Collaborative at the Vermont Agency of Natural Resources, and then also spent time as the land use and water quality educator at Lake Champlain Sea Grant. Her current focus is largely on hydropower relicensing and dam influence on riverine systems, but she also does work related to lake watershed action plans, volunteer water quality monitoring, data analysis for Lewis Creek Association and Addison County River Watch Collaborative, work on de-icing salt monitoring in rivers and wetlands, and pollutant movement tracking from permitted operations. So Becky graduated with her Ph.D. in what at that time was called Plant and Soil Sciences in 2018, working directly under Stephanie Hurley, and then I served on her committee back then. Also has a master's from UVM in natural resource management. John Todd was her primary advisor, as well as her committee members included Donna Rizzo, who's still with us at UVM as well. And before that, she had a BA from Harvard in Extension Studies. So this talk will be about 30 minutes with 15 minutes of Q&A at the end. Please hold your questions until the end. And if you are joining us on Zoom, you can enter your questions into the chat box at any time during the presentation. Hannah is here and will be monitoring those questions so we can make sure those get to Becky. But welcome, Becky. It's great to have you back. Just one little personal thing. Becky and I have done various things, work related together over the years, and we just always laugh a lot. We were laughing already today. It's just always fun working with you. So welcome.
Awesome. Thanks. Thanks, Eric. It's so good to see some friendly faces in the audience. It's nice to be back on campus. I haven't been here in a while. So thanks for coming over. So I have a question to start. If a hydropower operation in Vermont, if a dammed river in Vermont was able to produce all of the power that we needed, and it's renewable and clean energy and it's affordable, but it impacts spawning walleye populations, should it be allowed to operate? And then as like a follow-up to that, like what if you could alter the operations of the plant so that it protects those spawning walleye, but as a result, we can only produce half the amount of power. So then we're left with a gap in the power need. Then is it okay to operate? And who makes that decision? And so what I'm going to talk to you today about is how I took what I learned at UVM and am now applying those methods and techniques and the science of water quality to sit at tables where those questions are being discussed and to bring some of the information that serves as the baseline for how we decide those questions. So as Eric said, I have all my graduate study was here at UVM, so I am UVM made. So you're all responsible for anything. But so I really have like two layered disciplines that are water quality based, both from the Rubenstein School and in Plant and Soil Science, which I didn't realize isn't called PSS anymore, because that's how long it's been since I've been on campus. But the layered disciplines are really looking at it from slightly different lenses, but both with the interest in engineered aquatic systems and how we can partner with natural systems to get a little bit more of the outcome that we're looking for in the engineered systems. And I also just want to point out, as Eric pointed, that Donna Rizzo was on both of my graduate committees, which just indicates that I owe her coffee forever. She was very gracious and taught me a lot. So between the two degrees, after I got my master's, is about a 7-year span. So I did some stuff in that time period. And I started working in extension. So I was first at the Winooski Natural Resources Conservation District, and then at the Lake Champlain Sea Grant Program, doing extension education. So doing like science translation education. And, I was doing green stormwater infrastructure type trainings and doing realtor courses. And it's also where I learned that I love working with Department of Public Works and municipal departments. These really are the places in a town where the town works. And these are the people that know how to get stuff done in the town. And they're also the front line of where policies that's where they're influenced. Like their daily life is influenced when there's like a new stormwater reg. And so I'm really interested in working with those people because they, first of all, are like the best and awesome and super smart and really know the systems. And then also because they're pretty far removed sometimes from where the decision-making is happening. And decision-making is sometimes happening in rooms, that are conference rooms and people are sitting around and they don't actually understand how like the physical reality of it is. So I learned that when I was doing this kind of extension education, but one of the things I also noticed was I wasn't getting to do any of the science. I was like the translator of the science, the extension of the science, and not really getting to ask the questions. And I wanted to ask a question. So I got some funding while I was at Sea Grant from the Basin program to investigate floating treatment wetlands as an augment to stormwater ponds to see if they could improve performance. And Eric was on my committee and he really steered that research to more of a foundational science perspective. Like really, we did a lot more biogeochemistry because Eric was there, and he led me to understand it. Even I think I was much more of like a practical, like implementation, like that's the direction I was going very clearly. And Eric was like, how about all of this stuff over here? How about this foundational science? And even though at the time I was like, I don't want to do that. Subsequently, I've realized like that has been that's the baseline of everything I do now. And it was really that kind of foundation. So for any of you that are in graduate school or considering graduate school and know that you may be pushed in directions you don't want to go in, it might be for the best, for the best in the end. But really got a lot out of that and asking those questions quite a bit. And when I finished the PhD, I went into consulting. I started working for Watershed Consulting Associates in Burlington, and they do a lot of stormwater related work. And I was really interested in work consulting because I felt like, oh, okay, this is where working on the science at the university. But then I was observing the consultants are really the ones who are doing these studies and like getting their hands dirty and getting to go out in the field. And that was like, I wanted to feel what that was like. I had worked at the agency, I'd worked at the university, and now I wanted to see what it was like doing consulting. And I got to do a lot of really cool work. We did pollutant movement monitoring. We did, this is a picture on the La Platte River where I first started doing chloride monitoring in the La Platte River marsh. And I still do some of that to this day in different places. And it was, some of the work was really impactful. If you've seen any of the stories in the paper about the farm in Panton, the lawsuits related to pollutant export, that was based on work I did. Now a couple of lawsuits related to that. And then just recently, this policy update about the bill moving its way through the Senate related to reducing road salt usage. And it was all based on work I did. So I felt like, oh, this is pretty cool. I'm like having a little bit of an impact as a little independent person. But then, and I got to do some like pretty, work doing watershed master plans in the US Virgin Islands on the island of St. John. But one thing when you work in stormwater that you realize is you spend very little time looking at beautiful vistas and a lot more time in ditches and at the outfalls. And I really wanted to spend more time in rivers. And then I got my first taste of doing hydropower research. So I did a small water quality study. I think I may have worked on it with you, Harrison. We did a really short run study on the Missisquoi River for Enosburg, which was they were just starting their relicensing process. And immediately it was like, oh, this like combines a lot of the stuff I love. I'm working with DPW, like, you know, these are a lot of the hydropower operations in Vermont are run by municipalities, and it's a department that's very similar to Department of Public Works. They know a lot about the operations of their hydros. And you also get to be out on these awesome rivers in Vermont, and it's really linked to an important energy policy that's happening. And so the science is impacting, it's making an impact immediately. The studies are really going to change or influence how operations happen at hydro. So around that time, I went out on my own and started my own consulting company to focus on hydropower relicensing. So if you're not familiar with hydropower relicensing, I'm going to give you a quick primer. The main thing you need to know is it's a lot. And it involves a lot of different agencies. You have the Federal Energy Regulatory Commission, FERC, but you also have all the state agencies, and you have advocacy groups and local groups, fishing interest groups, recreation groups, and everybody has an interest in the river and how the river is used. And in a hydropower license from FERC is a 30-year license period. So it's infrequent that they are renewed, but when they are, that's like the opportunity for everyone to be like, well, let's look at this carefully again. So it really triggers a lot of interest at the time of the relicensing. And there's also these nested responsibilities during the relicensing. So multiple agencies may want a similar study, but they want slightly different methods or in slightly different locations. And so there's a lot of negotiation that has to happen. And for a municipality that happens to run a hydro, this is a huge undertaking. You don't do it very often. So for most people who do it, they do one. If you're working for a hydro, you're doing one of these in your career. And so it really highlights the role of consultants to help in that process, because otherwise you have no other framework for how this would be done, except if you've done it before. And so why it's important, why does it matter? More than half of all the power that's produced in state in Vermont is hydropower, but most of our power comes from out of state. And so we have very little control over where we're getting that. And some of that's coming from Hydro-Quebec, and they're producing hydropower, but using methods that Vermont, that the agencies in Vermont don't support. So we are getting that power that's being generated from use of methods that we may not support internally, but we're still contributing to the purchase of that. It's historically one of the cheapest generation sources in Vermont. We're lucky that we have a history of hydropower, and we have a lot of rivers, and we have a lot of water, and in many cases, we already have the infrastructure there. So the startup cost, both from a carbon perspective and a cash perspective, is much lower for a place like Vermont where you already have some of the infrastructure. A lot of the infrastructure that's already in Vermont is quite old, as it is, and most of them are small, distributed, and locally controlled. This is a watershed area of the Missisquoi River. You see that the Missisquoi River it goes up into Canada, so you have a little section of it. It's up into Canada. It's a pretty big watershed, covers a lot of the northern part of the state. And you can see on there, all those little stars are all hydropower plants. So you can see just on one river in Vermont, one big river, there's a lot of hydropower. This one down here, Swanton Dam, it's on the map, but it actually isn't an operational hydroelectric facility, but there is a dam there. And that'll become important, or you'll see it, you'll see that a little bit later. And I'm just going to talk to you. I've worked on two projects, two of these hydroelectric projects that have been relicensed in recent years on the Missisquoi, at Highgate and at Enosburg Falls. And this is the case study I'm going to talk to you about. So for Highgate, this is the picture on the left is a picture at the impoundments. This is the intake into the turbines and the generating station. Highgate has a couple different turbines. One of them is right at the dam, so they call it their minimum flow unit. So basically it enables them to not lose any of the power. In a lot of instances, there's a bypass for each of a river, so that you can't just take all the water out of a river, run it through the turbines, and then put it back into the river, because you have a section of river that there's no water in it. And so that's not allowed. But Highgate has this unique situation where they have a little turbine right at the dam, so they don't lose any of the power just from pushing that water over the dam. So they're able to generate power with every bit of water that comes by. Gives them a little bit more flexibility than some of the others. And this is, so the picture on the left is downstream of the dam. There's a little buoy there just set up for one of the water quality studies that I did. And there were a ton of studies. This is a partial list of the studies that were requested and completed for the Highgate relicensing. And this isn't uncommon. This is the time when all these studies are requested. So you got archaeological studies, you got water quality, habitat studies in different areas for different reasons, bank erosion studies up and down the length of the river, both in the impoundment and downstream, operations assessments, impingement and entrainment studies, recreation surveys, aesthetic studies. I mean, it's vast. It's a lot. And I'm going to talk to you about these downstream flow and habitat modeling and the downstream level fluctuation that I worked on there. So this is a map of the lower part of the Missisquoi. That upper part where you see it says Highgate Falls, that's the location where the Highgate Dam is. And then all the way down here past where Transect 5 is, that's where the Missisquoi National Wildlife Refuge is. And just past that, it opens up into the lake. So it's about 14 miles of river between Highgate Falls and the lake. And in between the two, there's also an additional dam. There's Swanton Dam. That was that one I was telling you about that isn't operational. It's not generating power, but it is a dam in the river. And because of that, it changes some of the dynamics of the river. When you dam a river, it's going to back water up behind it. And so it changes some of what the river would look like if it didn't have water backed up behind it. And because of that, and the agency is interested and concerned about fish migration between the lake and then being able to get up the river. Now, Highgate Falls, even if the dam wasn't there, there's a natural barrier because it's a very high falls. It's naturally a narrowing point in the river, and there's a very tall natural waterfall in that location. But in between Swanton Dam and Highgate Dam, there's restricted fish movement because of the dam there. And so the agency was interested in knowing a lot about how Highgate Dam operation was influencing water level and velocity and in turn fish habitat up and down the whole length of the river, so for 14 miles. So we set up transects. So the way we did this, also just to reiterate, there's all these different transect locations, and we were collecting 15-minute increment data about water level over maybe 9 months or something like that. And then at 3 of the transects, getting a lot more detailed information, doing contours and velocity measurements at calibration flows, and then modeling for 6 additional flows, and then turning all of that information into habitat models to compare to the species of interest. So it sets up all these interesting, technical challenges. So the river at one location is about 560 feet across, and I have a 500-foot-long tagline. So it's just like, what are we gonna do here? There's a lot of jerry-rigging involved. But you figure it out, and then at the end, you get all this data. So we have like tons of information about how fast the water is coming up and down on the length of the river and when it's coming up and down related to hydro operations versus a storm event. We have all this information about water level across these 3 transect areas and all the velocities associated with that. And then we take all that information and feed it into a 2D model to understand fish habitat and how the fish are influenced in all these different operational scenarios and all these different transect areas. And what you get at the end is a lot of different information, but who's asking and why are they asking the question for all this data? And this is where it gets kind of interesting. So if the question is very simple, like how do we make habitat for spawning walleye better at this one particular cross section in the river? Well, we can answer that really simply with all that stuff I just showed you. And we can just highlight that one particular variable and say that's how you do it. But that's not real life, because it's never just about the walleye. Just like it's never just about the power generation. It's never that simple. There's a lot of trade-offs that you have to account for. And how the question is asked, or who asks the question, interestingly kind of changes the science at times. And I think that's kind of maybe a novel thing to think about, especially if you're in your science training, where you might really be desiring to find like the answer. And in the world, if you go to work as a scientist in the world, I think you will find that the answer is so influenced by who is asking the question, why they're asking the question, and what's embedded even behind that question that isn't on the table. So in the case of Highgate, the question was really clearly about this suite of fish species. Now, it wasn't just one. So even in that one example, I showed you we had 20 different species and life stages that we were trying to optimize for. And even in that case, if you optimize for the spawning walleye, well, the fall fish are very unhappy at that particular thing. So it's even if it's all about fish, you're still making trade-offs and you're trying to optimize. Oh, and I want to call out that this is another UVM grad. This is Dina Cordes, who graduated from in RCNR actually with a Bachelor of Science, and she came to work with me for a summer, and now she's studying to be a chemistry teacher. But it was just another awesome person that came out of UVM. So there's a lot of, and got right out on the rivers and did a lot of cool work with me. So what about if fish isn't the only outcome that we're interested in? So I'm just going to pivot a tiny bit and tell you about an interesting example in the Green River Reservoir. Is anybody familiar with the Green River Reservoir? You've seen it in the news recently? So it's a really interesting case, and I think it's particularly interesting in light of this other licensing that's happening. So if you're not familiar, the Green River Reservoir is created by this dam, and it backs up the water and creates this reservoir. It's not actually particularly old, and it's been operated as a hydroelectric facility by Morrisville Power and Light, who own and operate a number of other dams on the Memorial River. When they were going through licensing, just like the study up in Highgate that I showed you, they had to do a bunch of studies, the same kinds of studies that they're doing in Highgate. And when they did their downstream flow study, and they did that model, what they found was there's some impacts at these particular different flows. And the agency's response is, okay, we need you to change operations because the goal is to protect these species. And some of the changes in the operations was to draw down or change the way water is drawn down in the impoundment. The impoundment in this case being a reservoir that we love, not just an impoundment on a river. And so that changes the lens through which we're actually looking at it. So Morrisville Power and Light essentially said, yeah, we can't change operations like that and without losing money, because the way you're trying to ask us to change the operations is totally different than the way we were operating before. We can't do it. We're not going to be able to make any money. That's fine. We'll just give up the license on that dam and we'll decommission the dam. Done. Well, state, we're like, well, no, I didn't want you to do that because the state doesn't actually want to lose that dam. If the goal was return fish habitat and rewild the rivers, this is a win. Decommission the dam, by all means. But that isn't actually the goal, because there's another use here that wasn't explicitly targeted in that fish study, and that is the recreation. So I was involved in this project in a tiny, tiny way with actually two other UVM grads, Dana Allen, who came out of PSS, and Stephanie Hurley's lab, and Holly Greenleaf, who both actually do consulting now. And Dana flew the drone, took this picture, and I took a bunch of depth measurements, and Holly did this photorealistic rendering of what it would look like if Green River was drawn down to the level that the agency request had been. And it's, it's a powerful image, because if you like to recreate there and you want to go boat and swim, or if you own a home on the reservoir, this really changes the condition, the existing condition of it. It's maybe more riverine, but that's not really what people have become used to. So just 2 weeks ago was in the news that a settlement's been, or an agreement's been reached between the agency and the applicant and FERC, that Morrisville Power and Light can continue to operate both this and the other hydroelectric facilities that they have, and that the agency will review their water quality rules as they relate to hydropower, to, you know, essentially understand, like, in what ways are our water quality rules maybe disincentivizing hydroelectric generation. So this is interesting, you know, opportunity for all of us to be honest about, like, what's on the table and what are we considering when we're making decisions. Because in this case, there was something was on the table that wasn't maybe clarified about whether it was on the table for this particular instance. So in all of those cases, there's a consultant in the middle of that. And as a consultant, you know, my interest in what I'm doing is collecting the data and analyzing it and displaying it. And my interest as a scientist is to, like, find the truth. And I don't always know what questions are being asked. I'm only told, you know, like, this is the study we need done, and these are the standard methods that you should be using. But it can be challenging to translate a study and the data in a study to meaningful results if you don't know why somebody originally was asking the question. And it's really about trade-offs. It's all about trade-offs. Everything's about trade-offs. And it's no different in hydropower than it is in anything else. And in a lot of ways, hydropower and hydropower relicensing forces us to consider these trade-offs in a really specific way. And it doesn't highlight, or it doesn't indicate bad actors. It does indicate that there are trade-offs being considered all the time. And we can do the best science and use the skills of the science when we can be clear about what our priorities are and at what time we're implementing those priorities. So hydropower forces trade-offs between recreation, clean energy production, water quality, habitat, and climate goals. And all of those are happening in the relicensing procedure. And we can do the best for all of us in the state, and we can do the best science when we understand which ones of the trade-offs that we're prioritizing at any given moment, and to be realistic that, like, they're all kind of important. And that makes it really complex and kind of tricky. Thanks, guys, for listening, and I'm happy to take comments and questions and critique. Yeah.
I was curious about the Swanton Dam. It's not functional. Why does it still remain? Is there any reason?
Yeah, it's a good question. It's a historic dam, and so the people of the town have own it. It's owned by Swanton, and there has been some attempts to repower it. Historically, it was used for power, but nothing's moving forward imminently. But there is, like, just a historic love for that dam. And so it doesn't seem like there's a lot of interest from the trustees of Swanton to eliminate the dam. There's a lot of fishing that happens immediately downstream of it. It's a really popular corridor for spawning fish. And it's actually a great spot to go if you're at all interested in this. If you go to Swanton in the spring, and there's the route, I think it's 108, that goes right over the river right there, and you can stand on it. And because it's so shallow below the dam, you can see huge fish right in the water right underneath it. So it's a popular place for anglers. They stand in the middle of the river on, you know, exposed ledge, and you can fish for giant. A lot of the guys down there, because I spent a lot of time collecting data down there, that there's a lot of, like, the old Swanton area folk who tell stories about the old days down there. And you used to be able to drive a boat right up underneath there. There was a hole, like a deep hole right below those ledges that was, like, people say 50 feet deep in the river. I can tell you, because I have measured, it's far from 50 feet anymore, but that's the kind of, like, lore about the good old days of fishing in that area. There used to be fishing shacks up and down the river, and it was like a thriving economy. So I think that's part of what is keeping that dam in place. Yeah.
I have a question about dam removal that maybe connects to this, because I think of Swanton as the place where like village identity and historic preservation meet dam removal. So it's a move in the state. Here's my question. There's been a fair amount of, I think, momentum around dam removal in the state over the last couple of years related to flood resilience.
Yeah.
Like conservation groups arguing, oh, we're going to do dam removal projects to increase flood resilience.
Yeah.
And I'm wondering what thoughts you have about that and what you think about the basis of dam removals
Yeah.
of varying types.
You know, the experience that I've had with dam removal, I'm actually working on a dam removal, well, I'm doing a water quality study for a dam removal that's in Enosburg Falls. So my understanding about the dam removal task force, as it's called in the state, is that they're prioritizing dams that are unused and in some cases like unknown, unmanaged. I mean, they're dangers, you know? And I think in that case, that's really smart. Like there are dams that are failing, and in an event of a large storm, it could be catastrophic if you have a lot of water built up behind those and then they fail and then you get flooding downstream. That makes a lot of sense. And I know the people who actually do these dam removal projects, which is often watershed groups, like you said, advocacy organizations, conservation districts. It's a ton of work to do, a lot of regulatory hurdles, a lot of engineering, a lot of pre-studies. And I think it's important in some cases. I think we have to be careful about applying it like dams are bad. And I have been concerned in the past to hear that there's been some undergraduate students that I've worked with at UVM who've gotten the sense through their environmental education that dams are bad. And I think that that's too simplistic of a conversation, you know, that's too simplistic of a result to get. And there's a ton more nuance, and there's certainly dams that should be removed. And there are some dams that we should be really grateful that we have.
There's all my questions. So Ashley Eden says this makes her think about the loon population on the Green River. The drawdown would have to be timed appropriately to not impact nesting locations. Was this a factor or part of the conversation on this dam project?
I don't know. I didn't work. I wasn't like a hired consultant for this. This has been going on for over a decade, this back and forth. Well, I think well over a decade. But some of the other consultants that I work with that have been in the field a lot longer. I think the interesting thing about the loon conversation is that in many cases, when we're talking about dams, especially from environmental groups, we'll say, we got to get back to natural conditions. That's our goal. Our goal is nature, nature, nature. Let's get back to a river. Loons didn't used to be on the Green River. They moved in because we made it not a river anymore. And now that's not like I don't have a stance on like anti-loon or anything, but I think it's interesting how like the narrative has flipped from the same groups that are like, we want nature, we want rivers. It's like, how about here? No, save the loon. I'm sure it was part of the conversation. I'm sure whoever was determining the drawdowns, they were aware of that. That's just my comment on the loon thing.
Not anti-loon. Okay.
Not anti-loon. Put that on that's cover.
I have one more question. Are you familiar of the relicensing problems on the Connecticut River / Wilder, Bellow, and Vernon haven't been assessed for stream bank erosion, fish ladders, or recreation in their relicensing?
Yeah, I'm familiar with that. That relicensing is currently in litigation, and so I'm not going to comment. Yeah.
Can you say a little bit more about how, so Vermont gets a lot of our power from Quebec, and you said how people in Vermont maybe don't support the methods that Hydro-Quebec uses to generate that power, which is different than the methods that possibly we use here.
Mm-hmm.
Is that the run-of-river methods, or can you just describe a little bit?
Yeah, so in Vermont, we have a lot of run-of-river, and especially in the recent relicensing, especially, well, in particular on the Missisquoi, because I know a lot about those ones, but even in the Connecticut River, those all of those relicensing that just happened in the Connecticut River, they went to run of river. So it's, we're moving in the direction of run of river typically in Vermont. And those, huge hydro plants typically don't operate as run of river. They do either pump storage or they're impounding and drawing down. It's what's called peaking. So you can back up behind the dams, you can have, all the, potential, power, and then you, draw it down. And so that's what in Vermont, generally, we don't do a lot of. And when we do, it's small, they're smaller fluctuations. And in larger systems, because they can generate a lot more power that way, they operate with a higher peak. So that's what we're talking about in Quebec.
Yeah. And I guess the follow-up to this is, I don't understand hydropower that well, but could we combine like run-of-river operations with battery storage? Because it's part of the problem is you want to release the water when there's a demand for energy. But if you can only do it slowly, can you store that energy in a different way when it's not demand?
It's a good point. I know people are talking about it. It's definitely the other side. I'm not an energy expert, and I'm sure there's probably somebody in this room who knows more about that than I do. But I have heard that talked about even in some of the relicensing of the old dams that I've been part of the relicensing efforts for. One of the ideas, one of the incentives would be like, well, we could do the storage with the battery technology. But I really don't know that much about it. Yeah.
I was curious, I don't know really anything about relicensing, but your description made it sound like sometimes the licenses are considered in isolation and sometimes they're considered with other downstream relicensing.
Yeah.
Are they ever considered as like a whole basin scale where you would try to like synchronize the relicensing so that you could think about more holistically what's going on in the whole basin?
It's a good question. Not that I'm aware of. And I know the licenses are, to the owner, to the individual, to the project. So in some cases, like for the Morrisville Power and Light, all of their projects were being relicensed at the same time because their licenses are in concert with one another. But like on the Missisquoi, for instance, there's a dam between Highgate and Enosburg that's owned separately and was relicensed separately. And they actually gave up peaking to go run of river, which before that relicensing had happened, as I understand it, the two operators would work together because they're both peaking. And so you do want to, the downstream people need to know when you're going to release so that they'll have enough time to fill up. And then, so I think in operations, they do coordinate, but I'm not familiar with a coordinated effort at a basin scale for the licensing process, but that does make sense. I mean, it makes really good sense, especially if you have a series of peaking projects that have timing built into the license. You could get off kilter if you're not considering the others. But I mean, all the studies that go into before the licensing takes into account operations of the upstream. It just isn't done at the same time that I'm aware of.
Interesting.
Yeah.
For going licenses private dams, right? Like not if you're a federal agency.
Yeah, like reclamation.
Right.
Yeah.
And so then when you as a private entity get the license to operate, determines when your license expires.
Yes.
And you need to re-up it.
That's right. Yeah. Thank you.
Was there much conversation over the summer when there was the drought and how that might have impacted these facilities and planning for that? Maybe?
Yeah, I mean, in a hydro, every day they're talking about water. That's all they care about. And there was a lot. Yeah, I mean, people couldn't operate this summer. There was a lot of, in Vermont, it's not uncommon that the summer times are a lower operation time for hydros, but this was exceptionally low. There's a certain low threshold at which you have to reach the flow in order to turn the turbines on in order for them to turn it all. And a lot of hydros weren't getting their minimum flow, so there was just like no generation through the summer, which is tough. Yeah.
Do you foresee us getting, as a state, more hydropower facilities in the future? Or because of a lot of the maybe sentiment that all dams are bad, you know? With all of our climate goals too, like that's a
Right.
huge.
Well, exactly. I mean, my hope, especially with this settlement or the agreement between with the state and the folks that operate the Green River Reservoir, like I think there's a real opportunity in the review of the water quality rules to consider what those climate goals are, because it's not embedded right now. And so I'm never doing a study and considering the climate goals. That's never part of it. It's never like, and how much of our generation are we able to meet with this? Right now, that's not really considered. I think that's a really good idea. It's probably what we should be going towards. And I'm not familiar with a lot of like new development of hydropower. I haven't, not that I've heard. Yeah, it's all dam removal.
Yeah.
And return to run a river, which reduces the ability to produce power. So that like 57% of our total in-state power generation from hydro will be lower next time we run those stats because we've reduced our capacity.
Kind of related. I'm curious how you think about like economies of scale with dams. Like in Vermont, we have all these small distributed dams. In Quebec, I mean, I don't know if they have small distributed dams as well, but they certainly have really big dams. Like, I'm just curious, it's kind of a nebulous question, but like, how do you think of those trade-offs of like a larger dam that produces more power versus these smaller distributed dams that maybe have compounding effects if they're on a river?
Oh yeah, no, that's a really good question. I have no idea. That's a very interesting question though, one that would be really worth like digging into. I think there's so many things we don't even know about, and then getting to like what Eric taught me and forced me to learn, and that I think about all the time, especially on impounded rivers, and that we do not study even as part of the relicensing is what's in those sediments. And then what is the relationship between the sediment that's being held back behind that dam and the overlying water column? Like even just that, because if you have a distributed system, you're having that impact all the way down in a way that nobody's measuring versus maybe, having one larger dam where there's more, it's more of an impact, but in a concentrated area, like that's even like an open question. So I don't know. That's you gotta tell me.
Another sediment question. In terms of certain trade-offs, we can mitigate impacts by moderating flow or building fish ladders, etc. But how do we frame the impacts to sediment transport, like starting downstream reaches or excess buildup behind dams?
Yeah, it's a great question. I mean, even in, I don't know, right? We'll start off with more questions, but I don't know. But I think that's an interesting question, even in the dam removal piece. Like oftentimes in preparation for dam removal, we're getting rid of all that sediment. There's oftentimes contaminants in the sediment. And so the sediment's being removed, but if you're trying to return a river to its natural condition, but there's been all of this historical sediment removed, like how do you account for that in the lower reaches? That's like, I don't know, that's complicated river dynamics questions. I don't know what the answer to it is. It's certainly another element. It's another thing to consider in the impact or the influence of a dam on a river, and that we're not actually explicitly asking in the relicensing procedure or ways that we could mitigate it. In some cases, well, I think in all cases, in impoundments, you will over time, it fills up with sediment, and that sediment is removed and it's trucked away. It's not distributed into the lower river. And I'm sure that, any river scientist will tell you that has impact. Yeah. That's me an easy one.
Okay. What do you feel like is most overlooked? Like, you were showing like all the assessments that are done when a dam like goes to this relicensing. Like, what would if you could include one more study? And then what would it be?
You know what I always want to do is, I want to look at temperature gradients way more. There's not really that much required for the gradient, and that's the question I'm always wondering. It's like, are you stratifying? How often are you stratifying in those impoundments? And then what are the characteristics of the impoundments that stratify? Do they have something in common? And then obviously, because you and I studied with Eric, we want to know, what about the release from the sediments? Like, what's in the sediment? Is that, how bound is the phosphate? Is it mobilizing? Are you actually creating more of a problem downstream? If you're not aerating? That's like the one I've proposed, to basin program like multiple times, and they don't want to fund me to do it, but I think it's a really interesting question. Yeah.
I have another what might be missing question. It's gonna take me a minute to spit this out, because I want to provide a little context.
Okay.
Among the speakers we've had in this series, all alums, you're our first in the consulting world.
Oh,
We'll have a few others. So it's been really interesting to me to hear you talk about these very practical, need to know kind of projects, as opposed to some of our speakers who have really been in the academic or federal agency research world.
yeah.
And then also, as you talk about UVM alums that you were employing, so I'm leading up to my question. We have at the Institute been involved in this other space where we are realizing there's this real shortage in Vermont of people in water operations to work at drinking water and wastewater treatment plants. And as you referred to operations repeatedly through your presentation, I've been kind of thinking, do we need to do something different? So here's where the what's missing comes in. Do we need to do something different at UVM to prepare our students for water operations?
Oh, that's a
more
great idea.
directly? Like maybe it's a micro certificate that like takes the academic knowledge that our students might learn in classes like you're teaching or I'm teaching, but help do that translation to what kind of stuff do you need to know to go out in the world and work in real water operations.
Oh, yeah, that's a great idea. And at the Highgate facility, there was the lead operator there that was there when I started doing the studies. He was tragically killed a couple of years ago. And as a result of that, the consultant group that I work on the relicensing with funded a training program in hydro in his honor, because he was a fantastic teacher and really understood everything about that hydro operation. And actually at that time, I thought like, oh yeah, I always hear about trainings for wastewater treatment or drinking water treatment, but this isn't like an avenue. I think that's an awesome idea, and we have some excellent hydro operations in Vermont that would be good to partner with. I mean, Morrisville Power and Light for sure. And I met, I think is it Scott Johnstone, I think is that. I saw him at, I think it was the REV conference a couple of years ago. And I'm pretty sure at the time he was talking about how he worked with some like engineering groups from UVM, some groups, and they were doing some projects with him. I think they're like hungry for that. They would be better to tell you like specifically how could you do that, like structure that training, but I think that's an awesome idea.
One more.
Okay.
Okay, your response earlier about the loons emphasizes the importance of understanding science and history of place. In your talk, you also referenced undergrad impressions and understandings from their environmental education experiences. It's clear that there's a need to foster the ability to hold this complexity of the issue. What recommendations do you have for environmental education practitioners to increase the caliber of critical thinking?
Oh, that's a great question. I mean, it sounds like the asker of that question has some ideas. I mean, I'm not an educator, and there are some fabulous educators in the room, and I was the beneficiary of learning how to critical think at UVM. I think that the program here, I was a graduate student here, so I think there's something different that happens at the graduate level. But being asked to not just come up with an answer, but also like consider the fact that it's very messy, which isn't that much fun. Everybody wants like a nice tidy answer at the end and be able to be like, and we did it. But I think like the messiness and being okay with like the fact that not everybody's gonna get everything that they want. And like letting students know that's okay. And I think the most important thing, and for me, the thing I've learned, is that the most important thing is that we be clear about what the priorities are and what the trade-offs are and what we're actually prioritizing. Like, I think before we talk about anything, we should be like, these are all the things and this is how they're being ranked. I think we could spend like all of our time doing that. And then the studies would do themselves. Yeah. Thank you. Thanks, everybody. This was a lot of fun. Thanks for having me over.
Wait, one quick presentation for you. When the Alumni Association learned that we were inviting alumni back, they came over with a bunch of gift bags.
Oh, no
And
kidding.
so thanks to the Alumni Association, and we've stuffed the bags hand and house with other WRI swag.
Who does it all around here, right? Thank you so
for
much.
coming and
Oh,
showing the
wow.
value of a UVM education.
Oh, thank you so much. Thanks very much.
Becky, before everybody heads out, first, thanks again for coming. It's great to see you. Thanks everyone for coming in person and those online. I did want to announce that on March 3rd, the next Water Resources Institute seminar will occur. It's titled The Value of Wetlands and Reducing Riverine Flood Losses. That's by Jesse Gorovich, who's also a UVM alum, did his Ph.D. In the Rubenstein School. So he's currently an economist at Environmental Defense Fund. So please join us for that one as well. Thanks, everyone.
Great.